Hello everyone, this is our third video. In the last video, we had already discussed some basic properties of legendre polynomial. Now, in this lecture, I will also continue this topic, some basic properties of legendre polynomial, and it is also called as the recurrence relation. This property is too much important on the view of exam view, and always asked in exam also. Therefore, I will solve here these two properties. I will solve first these properties. N plus 1 into Pn plus 1 of x is equal to 2n plus 1 of x into Pn of x minus nPn minus 1 of x on the basis of generative function of legendre polynomial. Now, consider the generative function of legendre polynomial is generative function of legendre polynomial. This is already discussed in last lecture. Generative function of legendre polynomial is g of xt is equal to 1 minus 2xt plus t square raised to minus 1 half is equal to summation over n is equal to 0 to infinity Pn of x t raised to n. Now, differentiating this equation, with respect to t, we get this equation 1 minus 2xt plus t square raised to minus 1 half. Okay. Now, this equation is similar to write this x raised to power n. What is the derivative of x raised to power n is n is raised to n minus 1. Therefore, write this term minus 1 half into 1 minus 2xt plus t square raised to n minus 1. Minus 1 half minus 1 is minus 3 half into again derivative minus 2xt plus t square is minus 2x plus 2t is equal to summation over n is equal to 0 to infinity t raised to n is n t raised to n minus 1. Therefore, n Pn of x t raised to n minus 1. Now, this 2 get cancelled here. Therefore, write this term x minus t into 1 minus 2xt plus t square raised to minus 3 half. Raised to minus 3 half, we will write this term minus 1 half minus 1. Therefore, I will write this term 1 minus 2xt plus t square raised to minus 1 half and minus 1. Therefore, I will write here denominator 1 minus 2xt plus t square is equal to summation over n is equal to 0 to infinity n Pn of x t raised to n minus 1. Now, this term going from this side, x minus t into 1 minus 2xt plus t square is generating function of legendre polynomial n is equal to 0 to infinity Pn of x t raised to n is equal to 1 minus 2xt plus t square into summation over n is equal to 0 to infinity n Pn of x t raised to n minus 1. Now, multiply this equation. X into summation over n is equal to 0 to infinity Pn of x t raised to n minus t raised to 1 and t raised to n is t raised to n plus 1. Summation over n is equal to 0 to infinity Pn of x t raised to n plus 1 is equal to summation over n is equal to 0 to infinity n Pn of x t raised to n minus 1 minus 0 to infinity Pn of x e raised to n plus summation over n is equal to 0 to infinity m Pn of x e raised to n plus 1. Now from this equation, comparing the coefficient of e raised to n on both sides, coefficient of t raised to n is x Pn of x is equal to x Pn of x minus n plus 1. Therefore, n is replaced by n minus 1. Pn minus 1 of x is equal to n plus 1 Pn plus 1 of x minus 2nx into Pn of x plus n minus 1 into Pn minus 1 of x. Now, rearranging this term from this form, first we will write this equation. This term n plus 1 into Pn plus 1 of x is equal to, from this term x Pn of x and x Pn of x is common. Therefore, I will write this term 2n plus 1 into x Pn of x, and this minus Pn minus 1 of x and n minus 1. Therefore, minus 1 plus 1 will cancel. Therefore, n Pn minus 1 of x. This will be the second recurrence relation. This is the three-term recurrence relation. Why? Because in this equation, Pn plus 1 of x, Pn of x and Pn minus 1 of x. From this three terms, therefore it is called as the three-term recurrence relation. Okay? From this equation, we have to put the value of n is equal to 0, 1, 2, 3 and so on. Then we will get also value of legendre polynomials P0 of x, P1 of x, P2 of x and so on. Okay? Now, we will discuss here this first property. Pn plus 1 dash of x plus Pn minus 1 dash of x is equal to 2x Pn dash of x plus Pn of x. From these two properties are very different. In this property, we will see here only the term of Pn plus 1, Pn of x and Pn minus 1. Here will be the dash is considered there. I will told here one thing. We have to solve kind of this property. Then you will solve this property. The legendre generating function of legendre polynomial you will differentiate with respect to t. But we have to solve this kind of property. Then you will differentiate the generating function of legendre polynomial with respect to x. Now we will solve here this second property. Now this property is very important, and question is always asked in exam on the basis of following property. Now, the generating function of legendre polynomial is g of xt equal to summation over n is equal to 0 to infinity 1 minus 2xt plus 3 square raised to minus 1 half is equal to summation over n is equal to 0 to infinity pn of x t raised to n. How this solve it? Then differentiating this equation with respect to x coordinate. With respect to x we get minus 1 half into 1 minus 2xt plus t square raised to minus 3 half. X raised to n is nx raised to n minus 1. Derivative of with respect to x is minus 2t is equal to summation over n is equal to 0 to infinity pn of x. What is the derivative with respect to x? Derivative is pn dash of x into t raised to n. Now this 2 get cancelled here. Therefore I will write this term for t into 1 minus 2xt plus t square raised to minus 3. I will write here from this form 1 minus 2xt plus t square is equal to summation over n is equal to 0 to infinity pn dash of x t raised to n. Now go this term from this side. This is t into 1 minus 2xt plus t square is the generating function. Summation over n is equal to 0 to infinity pn of x t raised to n is equal to 1 minus 2xt plus t square into summation over n is equal to 0 to infinity pn dash of x t raised to n. Now multiply t raised to 1 and t raised to n is t raised to n plus 1. Summation over n is equal to 0 to infinity pn of x into t raised to n plus 1 is equal to summation over n is equal to 0 to infinity pn dash of x t raised to n minus 2x into summation over n is equal to 0 to infinity pn dash of x t raised to n plus 1 plus summation over n is equal to 0 to infinity pn dash of x t raised to n plus 2. T raised to n and t raised to 2. Now comparing the coefficient of t raised to n on both sides, t raised to n plus 1. Therefore here n is replaced by n minus 1. Summation over n is equal to 0 to infinity pn minus 1 of x is equal to pn minus 1 of x is equal to pn dash of x minus 2x into pn minus 1 dash of x plus pn minus 2 dash of x. Now from this term n is replaced by n plus 1 n plus 1 minus 1. Therefore pn of x is equal to pn plus 1 dash of x minus 2 dash of x. Now rearranging this equation, from this form, Pn plus 1 dash of x plus Pn minus 1 dash of x is equal to